Before we begin this lesson, you need to make sure that your calculator is in degree mode. So it must be in degree mode. So if you type into your calculator, you should see the button that has a TAN on it. And press that tan button, and then 30 for 30 degrees. And press enter. And when you do, you should see 0.57735. If you do, then your calculator is in degree mode. To double check, you can also do the tangent of 45 degrees here, and that should equal 1. If your calculator does not give you that, then your calculator is not in degree mode. So what it should have is it should have a D or a DEG on your screen, somewhere usually along the top or along the bottom of your screen. If it has an R, a G, an RAD, or a GRAD, you're in the wrong mode. To change the mode on your calculator, it depends on which calculator you have. Sometimes you have to press mode and then go to degrees, and sometimes your calculator will have a button that says DRG, and you will press that, and then that will take you into the mode to change the mode. So I posted one document on Edmodo, and the document looks like this, that has two of the most common calculators that I usually see students have. Maybe yours is a different color, but it might look like one of these two. If you have one of these two, you can read these instructions from Edmodo on how to change your calculator into degree mode. If you do not have one of these calculators and you cannot figure out how to change it into degree mode, then please email me a picture of your calculator if possible, or just email me what it says at the top of your calculator. For example, this is a TI-30X2S and a TI-30XA, and I can look up your calculator online and figure out how to tell you to change it into degree mode. In order to continue with the rest of this chapter, you must have your calculator in degree mode. So here on these calculators, they both have a DRG. So right here is the DRG button, and right here is the DRG button. When you press that DRG button, then you're going to choose degree. It probably says DEG. I do not personally have these calculators at my house, so I can't actually do it, but together we'll be able to figure it out. So please email me if you don't know how to use your calculator and it's not in degree mode. Okay, let's continue with the lesson. So you should have out your VTP as well as your next couple pages of notes. So first on the VTP, lesson 9.3. Nope, lesson 9.4, we already did 9.3. So here we have the tangent ratio. At first blank, a trigonometric ratio it's a long one, squeeze it in there, is a ratio of two sides of a right triangle. So again, this has to be a right triangle. And we do have three trigonometric ratios. The first ratio we're going to talk about today is called the tangent ratio. I'm writing really big today. So this is abbreviated TAN, and that's the button that you guys just tried on your calculator. So what you would do is you're going to choose an angle. So here, we're going to look about for angle A. So if I choose angle A right here, the side that's opposite angle A, we're going across from angle A, is side BC. So BC is the opposite. The side that's adjacent to angle A is the side that's touching that angle vertex, but not the hypotenuse. So adjacent would be this one here. So that's side AB. And then the hypotenuse, obviously, is across from the right angle, so that is AC. Now using these three sides, the tangent of an angle is going to be the opposite divided by the adjacent. So the tangent of angle A is equal to, I'm going to write that below here, the opposite divided by the adjacent side. And that's what it's always going to be. The tangent of any angle is always that. So for angle A, the opposite side we just identified was going to be BC. So it's going to be BC over the adjacent side we just said was AB. Perfect. Well, now for angle B, oops, that's a typo there. That should be, cross this off right here. This should be angle C. We never take the tangent of the right angle. We only do the non-right angles. So there I circled angle C. So if we want to find the opposite, again, divided by the adjacent, the opposite side of angle C is all the way across. So that's AB now. So AB now is the opposite side instead of the adjacent. Then the adjacent side is this one right here. It's going to be side BC. And this is the tangent ratio for all right triangles. If you flip your VTP over onto the back, we have one more thing in this section, and that's called an angle of elevation. Angle of elevation. This is an angle that's formed by a horizontal line. So let's say like the ground. A lot of times we'll be talking about the ground. And then we might say like, how tall is the tree? If your angle of elevation is a certain degree, and then you know one dimension. So an angle of elevation would be like, let's say you're here on the ground and you're gonna look up to the top of the tree. This angle right here is my angle of elevation. That angle of elevation then can be used. We can make a right triangle with this. So we can make our right triangle here, and then we could find other information about this triangle using trigonometry. Now let's switch to the notes for today and do a few of the first examples. So we'll start out with page 260 and page 261 of your student journal pages. These first three examples are just asking us to identify the tangents of the acute angles in the right triangle. We'll write them as a fraction, and then we'll write them as a decimal rounded to 4 decimal places. So we'll do that for each of the two angles. So on this first triangle, let's do the tangent of angle S first. And we don't have to actually write the angle symbol. We can just do the tangent of, and then just the capital S is equal to. So again, we need the opposite side. So from S opposite, we have 24. So we're gonna have 24 divided by the adjacent side here. Well, the adjacent side is going to be the one that's touching, that's not the hypotenuse, so that's going to be 45. So it's 24 divided by 45. And then we can calculate the decimal equivalent to that. So we just type that into your calculator, and we're going to get, well, actually, let's reduce it first. That would reduce by a 3, so 3 goes into 24 8 times and into 45 15 times. So we actually have 8/15. And then it's approximately, make sure you're using the squiggly equal sign, type it into your calculator. We'll do, it says 4 decimal places, so 0.5333. So the tangent of S is equal to 8/15, which is approximately 0.5333. We can do the same thing for angle R in the same triangle. So angle R in this triangle, here's angle R. So the tangent is going to be the opposite side. So identify the opposite side. So you should see opposite going all the way across. So that's 45 divided by the adjacent side. So not the hypotenuse, but the one that it's touching here, which is 24. And we can also reduce that. So 45 and 24 also reduce by 3. So 45 becomes a 15, 24 becomes an 8, and we got 15/8. So tangent of R is that. And then it's approximately, we plug it into our calculator, we get 1.8750. And that's how we find the tangent of that angle. All right, let's go ahead and do example number 3. We're going to skip number 2, so don't worry about that one. So example number 3, if we find, let's do angle C first. So angle C, the tangent of C is equal to the opposite side, square root of 2, divided by the adjacent side. So this is the hypotenuse, so we don't want that, we want the 2. So square root of 2 divided by 2. That does not simplify, but we can calculate that on our calculator, and that is approximately 0.7071. Next, let's do the other angle of this triangle. So we're going to be doing angle A here. So looking at angle A, identify which angle is the opposite side. Across from A, there we have it. It's 2. divided by the adjacent side, so touching but not the hypotenuse. That's square root of 2. Now we all know we can't leave it like that, so let's multiply it by the square root of 2 over the square root of 2. And then that will give us 2 square root of 2 over 2. And then I can cancel the 2's, and I'm simply left with the square root of 2. So the tangent of A is the square root of 2. Give myself a little more space here, which if I plugged it into my calculator is approximately 1.4142. And that's the basics of calculating a tangent value. This is lesson 9.4 part 1. I'm going to end this video now. You can take a break and then come back and watch 9.4 part 2.